everyone. How are you doing today? I'm glad to be here today. I am Lee Chai Mei from Sekolah Menengah Teknik Tuanku Jaafar, Seremban. Today, we are going to learn about the surface area of three-dimensional shapes, also known as 3D shapes. Please make sure you have a scientific calculator and a notebook with you. Let's get started. Boys and girls, before we start, can you recall some of the 3D shapes you have learned? Let's name them. This is a cube. This is a cuboid. This is a pyramid. And this is a prism. Well done! You can name all of these 3D shapes correctly. By the end of today's lesson, you should be able to first, derive the formula of the surface area of cubes, cuboids, pyramids, and prisms, and hence determine the surface area of the shape. Second, solve problems involving the surface area of cubes, cuboids, pyramids, and prisms. Boys and girls, we know that 3D shapes are formed out of 2D shapes. I'm sure you know how to calculate the area of 2D shapes. How do we calculate the surface area of 3D shapes? Let me share with you some tips and tricks. First, we lay out the net of a 3D shape. Then, we add up the area of all its faces to obtain the surface area of the 3D shape. In simple words, the surface area of a 3D shape is the sum of the area of all its faces. Let's make a short recap on the net of cube and cuboid. Let's take a look at the first example. This is a cube. Observe the cube carefully. At the same time, try to imagine the net of the cube. The net of the cube is as shown. We know that a cube is made up of 6 squares. Therefore, the surface area of a cube is 6 multiplied by the area of a square. Well, it is as simple as that. Let's look at the next one. This is a cuboid. How many rectangles and squares are there in a cuboid? That's right. The cuboid is made up of 4 rectangles and 2 squares. To calculate the surface area of the cuboid, we add 4 multiplied by area of a rectangle and 2 multiplied by area of a square. Up next, let's proceed to learn about the surface area of a pyramid and a prism. Before that, let's do a quick recap on the net of a pyramid and a prism. Let's discover how to find the surface area of a pyramid. This is a square-based pyramid. It is called a square-based pyramid because the base is a square. As simple as that. Look at the pyramid carefully. Can you observe how many triangles and squares are there in this pyramid? Excellent! The pyramid is made up of 4 triangles and 1 square as the base of the pyramid. So, how do we calculate the surface area of the pyramid? That's right! The surface area of the pyramid can be calculated by adding 4 multiplied by the area of a triangle and 1 multiplied by the area of a square. Let's compare. Both of these 3D shapes look quite similar. They are pyramids. We have just learned that the pyramid on the left is called a square-based pyramid. Can you guess what is the shape of the base of this pyramid on the right? Yes! On the right, the base of the pyramid is a triangle. Therefore, it is called a triangular pyramid. Let's explore the surface area of a triangular pyramid. The layout of a triangular pyramid is as shown. The base of this triangular pyramid is an equilateral triangle. This triangular pyramid is made up of a triangular base and 3 triangular faces meeting at the pyramid apex. To calculate the surface area of this triangular pyramid, we add the area of the base triangle and 3 multiplied the area of the triangular faces. This is a prism. To recall, a prism is a 3-dimensional shape with 2 identical shapes facing each other. The identical shapes are the cross-sectional parts of the prism. A prism is named according to the shape of the cross-section. Can you name this prism? Well done! Specifically, it is called a triangular prism because its cross-sectional area is in the shape of a triangle. A triangular prism has 3 rectangles and 2 triangles. Therefore, the surface area of a triangular prism is 3 multiplied by the area of a rectangle and add 2 multiplied by the area of a triangle. Do you know that we have different types of prisms? We mentioned earlier that a prism is named according to the cross-section of the prism. Here, we have a rectangular prism and a trapezium prism. Can you figure out how to find the surface area of these prisms? It is as simple as 2 multiplied by the area of the cross-section and add the area of all the lateral faces. You are doing great! By calculating the surface area of the cube, cuboid, pyramid and prism, we clearly understand that the surface area of a 3D shape is basically the sum of the area of all its faces. We have learned the formula to determine the surface area of the 4 3D shapes. Now, let's apply what we have learned to calculate the surface area of the objects around us. Let's do some problem-solving questions. The first question. Jenny wants to send a parcel to her friend in Singapore. She wants to wrap the parcel with 1 layer of bubble wrap before passing it to the courier service. What is the minimum amount of bubble wrap needed in square centimeters to wrap this parcel? Let's find out. The box is the shape of a cuboid. The base of the box is square. Hence, this box is made up of 4 rectangles and 2 squares. To calculate the surface area of a cuboid, 4 multiplied by the area of a rectangle, add 2 multiplied by the area of a square. The area of the rectangle is 14 centimeters times 8 centimeters, whereas the area of the square is 8 centimeters times 8 centimeters. Insert the values into the equation. 4 multiplied by 14 times 8 and add 2 multiplied by 8 times 8. 4 multiplied by 14 times 8 equals 448, and 2 multiplied by 8 times 8 equals 128. 448 plus 128 is 576 square centimeters. Therefore, Jenny needs at least 576 square centimeters of bubble wrap for this parcel. The second question. Ken is going camping with his friends. He wants to use a piece of polyester to make a tent. Can you help Ken to calculate the amount of polyester in square centimeters needed to build a tent as shown in the diagram? I'm sure you can do this. Bear in mind, first, we have to identify the 3D shape. Well, the tent is in the shape of a pyramid. We can see that this pyramid is made up of 4 triangles and 1 square. Therefore, the surface area of the pyramid is 4 multiplied by the area of a triangle and add 1 multiplied by the area of a square. The area of the triangle is 1 over 2 times 5 times 8, and the area of the square is 5 times 5. Substitute the values into the equations. 4 multiplied by 1 over 2 times 5 times 8, add 5 times 5. 4 multiplied by 1 over 2 times 5 times 8 equals 80, and 5 times 5 equals 25. What is your answer? Good job! The amount of polyester needed to build this tent is 105 square meters. The third question. Mr. Lee bought a Rubik's Cube for his son. The total surface area of the Rubik's Cube is 294 square centimeters. Can you help Mr. Lee to determine the length of P? A cube is made up of 6 squares. Hence, the surface area of a cube is 6 multiplied by the area of a square. Given that the surface area of the Rubik's Cube is 294 square centimeters, Therefore, 6 times the area of a square equals 294. How do we find the area of a square? Yes, it is P times P. Hence, 6 times P times P equals 294. 6 times the square of P equals 294. 294 divided by 6 is equal to 49. We will get P square equals 49. What is the value of P? Well done! The square root of 49 is 7. Hence, the length of P is equal to 7 centimeters. The fourth question. Dalila wants to give this chocolate to her friend. She plans to wrap it up as a gift. Can you help her to calculate the minimum amount of gift wrapping paper needed to wrap this chocolate? We notice that this chocolate is in the shape of a triangular prism. In order to calculate the amount of gift wrapping paper needed, we need to find the surface area of the chocolate, which is the surface area of the prism. We add 3 multiplied by the area of a rectangle and 2 multiplied by the area of a triangle. To find the area of the rectangle, we need the length of x. How do we find x? Perfect! We use the Pythagoras theorem. Square root of 3 squared plus 4 squared. The length of x is 5 centimeters. We can now find the amount of wrapping paper needed to wrap this gift. The length of the chocolate is 20 centimeters. For the sides, the area of the rectangle is 5 centimeters times 20 centimeters. For the base, the area of the rectangle is 6 centimeters times 20 centimeters. Whereas for the cross section, the area of the triangle is half times 6 centimeters times 4 centimeters. Substitute the values into the equation. 2 multiplied by 5 times 20. Add 6 times 20. Add 2 multiplied by half times 6 times 4. We will get 200 plus 120 plus 24. What is your final answer? Well done! Dalila needs at least 344 square centimeters of gift wrapping paper to wrap this chocolate. You are very good at solving everyday problems involving surface area of three-dimensional shapes. You have done a great job. Let's discover a fun fact. This is a human brain. These folds or wrinkles serve an important purpose. They effectively increase the surface area of the brain, thereby increasing the number of neurons within it. At the most basic level, more neurons lead to more connections and therefore a more efficient brain. In fact, it is so heavily folded that if you were to spread it out, it would cover 0.23 square meters. Human brains are wrinklier than the brains of any other animals, which is a key factor in our higher intelligence level. I have an activity for you to explore. You are a candy container designer. You have been hired to design a Christmas-themed candy container for a candy shop. Your candy container can be in any of the three-dimensional shapes that you have learned today. Your candy container must attract the attention of the candy buyers. You can start by drawing a sketch of a net on paper. Your net should be measured to the actual size of the product. Bear in mind, our objective is to calculate the surface area of the candy container. This project can be very interesting. It's a combination of maths and arts. Getting excited? Use your creativity to design the candy container after the lesson. Have fun! We have come to the end of the lesson. Now, you are able to derive the formula of the surface area of cubes, cuboids, pyramids, and prisms, and hence determine the surface area of the shapes. Besides that, you are able to solve problems involving the surface area of cubes, cuboids, pyramids, and prisms. I hope you enjoyed today's lesson. Thank you for your attention. Goodbye.